Our world is moving at a faster pace. We're more agile and dealing with larger amounts of information than ever before. And our reliance on energy continues to grow for homes, devices, transportation and much more. We are entering a new era in which technology in the consumer world is merging with the industrial world. A convergence of big data and software in sectors like power generation is known as the Industrial Internet. Here in Ireland, this revolution is underway with software and data analytics from General Electric, which enables an existing power plant to operate more reliably and efficiently.
So on some of the most critical equipment, we've installed new sensors which allow us to actually monitor the current waveform going to the equipment and gives us very valuable data on how the equipment is running.
GE has developed a unique solution at the Whitegate plant, connecting existing and new monitoring systems in an entirely new way. GE's Reliability Excellence software sends data about how each part of the facility is performing. The application identifies early warnings of anomalies or pending issues through round-the-clock monitoring and diagnostics across the entire plant.
The same information we can monitor in the control room, we can also monitor on any mobile device, an iPad, etc. We're very excited about it here because what it does is it's giving us more information and usable information. It's allowing us to make better decisions. So what you're doing is actually making it a much more intelligent power station.
We have one consolidated view of the plants. It brings a lot of real-time data together. So it's good to give us an early warning that there may be something not quite right on the plant.
This is a power station where machines and people interact to predict problems before they occur.
Through the performance monitoring, we're able to see that we were using about 25% more gas than what would be expected at this level of load. We found that the valve setup was actually done incorrectly, and correction of that reduced gas consumption by 25% again.
It's the Industrial Internet at work. The result? A cleaner, more efficient and reliable power plant.
We hope that our availability in the market will improve and reliability will improve as well.
We've got very big machines out there, and the software that GE is developing is not just about collecting big data from these machines, it's about turning that data into useful information, into intelligence that can help us make better decisions.
Motors, pumps and other motor-driven equipment are used in many industrial environments, in power plants, underwater, in the offshore industries, and in refineries. All this equipment has to be monitored for wear and faults. If the motors aren't subject to a well-implemented maintenance program, they can benefit from a low-cost, easy-to-install condition monitoring solution. That solution is GE's Bentley Nevada Anom Alert. It's an independent, proactive condition analysis tool that complements your existing condition monitoring platforms. Anom Alert detects small changes in motor performance over time, changes that are leading indicators of impending failures. These indicators enable you to take appropriate action. That could mean changing operating conditions, removing the motor from service, or making no changes at all. Whatever the case, Anom Alert gives you much better information to make informed decisions. Let's take a closer look at a refinery. Stacked with motors, pumps and filters, it's not always directly accessible for checks and maintenance. Anom Alert detects anomalies by measuring the current and voltage signals from the electrical supply to the motor. As a result, It detects both mechanical and electrical anomalies. It also monitors electrical parameters, such as voltage and current imbalances and power factor. What's more, it can detect changes in the motor load due to anomalies in the equipment being driven, or issues like cavitations or plugged filters and screens. Anom Alert doesn't require any sensor installation in the motor itself or its associated load. Anom Alert is particularly suited to inaccessible equipment and can be used for most types of pumps, compressors and similar loads. Anom Alert is easy to install and configure. Once this is done, it rapidly reports on the motor's condition and makes any necessary recommendations for further action, including energy efficiency and consumption improvement recommendations. Anom Alert is typically installed in the motor control cabinet. Both the sensors and Anom Alert instruments are small in size, so they can be easily installed in almost any convenient location. All a motor needs is one Anom Alert monitor, and it can be configured entirely from the user panel. Each Anom Alert monitor includes Anom Alert software. As well as displaying real-time data from the device, the software enables you to configure the device's performance and save and retrieve data. The user interface gives you multiple views of the motor data and motor condition. Color-coded indicators provide immediate updates on motor status and appropriate actionable information. Anom Alert builds a model of the initial power characteristics of the motor and load. Changes in the motor and its load are reflected in the power spectral density plot. The shape of this plot provides you with specific diagnostic and condition information through various displays. Anom Alert first learns the equipment it's monitoring. After that, it provides information about the equipment's current condition. This includes automatically identifying any weak points in the equipment. Pressing the PSD button displays the equipment's frequency spectrum. Any abnormal peaks in their frequency indicate weak points that may result in faults. Thanks to Anom Alert, maintenance personnel can easily locate the faulty device. Anom Alert doesn't replace existing condition monitoring technologies. Instead, it improves the efficiency of your condition monitoring program by eliminating the need for regular data collection routines. By identifying a potential motor problem early, Anom Alert alerts you that further investigation is needed, like vibration, thermography, or lubrication analysis. Anom Alert is a simple, innovative solution that detects mechanical and electrical anomalies in the motor and its load. By complementing other condition monitoring technologies, it optimizes your maintenance programs. As a result, it increases equipment availability, improves your maintenance planning, and reduces unexpected outages.
The AnomAlert Motor Defect Simulator provides electrical and mechanical fault simulator functions. It is based on advanced hardware and professional design. It is flexible and robust, cost-effective, and useful for demonstrating the functions of AnomAlert for training purposes. It is a handy, easy-to-use simulator which can be useful in training personnel for the operation of AnomAlert and for the use of AnomAlert in diagnosing machine anomalies. The main differences between the Pro and the Lite version of the AnomAlert Motor Defect Simulator is that the Pro version features a built-in industrial PC running an AnomAlert server. The Lite version does not have a built-in PC. Here we have the AnomAlert Motor Defect Simulator. As you can see, this enclosure contains all of the hardware necessary to simulate an operating environment for the test motor. It also contains an industrial PC running the AnomAlert server software so that this AnomAlert test unit can be interrogated from anywhere in the world with an internet connection. Here on the lower half of the panel we have the controls necessary for introducing simulated faults on the test motor. We also have some indication. We can see here there is current per phase and also phase voltages. Along here are the push buttons for introducing electrical faults. We can introduce a turn fault on either U, V or W phase simply by pushing the simulation start button on the corresponding phase. Resetting is as simple as pushing the normal state push button. We can also introduce earth faults. At the flick of a switch, an earth fault is introduced on the test motor's stator winding. There are two levels of earth fault, fault 1 and fault 2. These simulate a higher impedance fault and a lower impedance fault. The test points at the bottom of the cabinet are used for connecting external measurement equipment so that the faults and their nature can be independently monitored with test instruments and the outputs from the AnomAlert verified. Here we have up close the test motor. As we can see, the test motor is a small 3-phase 180 watt induction motor. This motor has been rewound with a number of extra taps in the stator winding so that stator earth and turn-to-turn faults can be simulated. This motor is coupled to a hysteresis brake. The hysteresis brake is used to simulate a load. It is controlled by an electronic brake controller so that precise load profiles can be simulated. Welcome to the AnomAlert software. Here we have the overview page. This page represents a quick summary of all the connected AnomAlert units. To the left, we have an equipment tree detailing information on all connected units. As can be seen here, there is only one device currently connected. This is the training simulator we have just seen, which is based in Pinkenba, Brisbane. To the right hand side of this window, we can see a summary of the equipment status and a summary of the electrical values. The spectrum page of the AnomAlert software shows the PSD plot, or power spectrum density. It is from this plot that mechanical faults are determined and derived. The various frequency bands are usually indicative of different mechanical problems. For example, the one under the cursor at the moment usually indicates issues with unbalance, misalignment, coupling or bearings. The report page of the AnomAlert software generates an automated report for the device selected. It can be seen here that the selected device is the training unit based in Pinkenba. The left hand side panel shows a summary of information on the unit being reported. To the right hand side we see a summary of faults on the unit. This is the Control tab. From here the AnomAlert unit can be directly interrogated and operated as if you were touching the front panel of the device itself. It can be seen that all of the machine parameters and settings can be adjusted and interrogated remotely. I am now going to introduce a turn fault on U phase. Here we have the overview page again. As can be seen here, the turn fault that was introduced previously has shown up as a watch. Every 90 seconds, AnomAlert calculates the parameters of the connected motor or generator and compares these values to its learnt model values. After some time, when statistical persistence criteria have been met, this watch warning will be elevated to an equipment status alarm and be flagged in the upper window. From this page, the trending for the appropriate alarms can be directly accessed. By double-clicking on the watch criteria, it takes us to a trending page showing the current balance values. It can be seen that by introducing the fault on the machine, we have caused a large rise in the current imbalance. This has been detected by the AnomAlert unit. Here we can see the AnomAlert unit is now indicating an alarm. This is due to the previously introduced fault having met the AnomAlert persistence criteria and being elevated to an alarm condition. Now back on the reports page of the AnomAlert software, it can be seen that one fault has been reported. This is described by the unit as a current imbalance exceeding 5%. It recommends to check for stator problems, short circuits, insulation problems, or partial discharge. It can be seen that short circuits is identified as a probable cause. This is accurate as a short circuit was deliberately introduced into the test machine.
AMT Toolkit is a revolutionary portable tool in the battle to keep electric motors and machinery running at peak performance whilst maintaining high plant productivity levels. Artisys AMT Toolkit was developed to meet a market requirement for a portable condition assessment product that can provide simple and accurate maintenance scheduling information without the need for interpretation by highly trained personnel. It aims to be very simple to install, set up, and operate, and to require little or no user intervention until an equipment fault is detected. This unique instrument is capable of monitoring three-phase AC motors and generators, as well as driven equipment of all sizes and power levels. It provides clear, unambiguous indications when the performance of a particular motor-driven equipment begins to degrade. The numerous transducers employed by other, less advanced instruments have been replaced by 3 current sensors and 3 voltage sensors, familiar to all those involved with the measurement of electrical quantities. The system is straightforward to install and use without in-depth training of personnel. Artisys AMT Toolkit is equipped with a computer, asset management units for data processing, Artisys Enterprise software for asset management, for generating a condition assessment report, as well as split-cord current transformers and cables. AMT Toolkit includes 2 asset management units with different current levels, so it allows to use both 1 ampere and 5 ampere current transformers, which are already installed into MCC cabinet. To get voltage connection, 3 insulated alligator clips are included in the AMT. Artisys AMT Toolkit is connected to motor cables using current sensors and voltage cables. It collects data for 30 minutes from motor-driven equipment and saves to SQL database to generate an instant condition assessment report. The total duration of the test is approximately 45 minutes to 1 hour, including the installation, stopping and starting the motor, data acquisition, and dismantling processes. At the end of the testing period, Toolkit generates a condition assessment report, which indicates existing faults in the system, recommended corrective action, and the effects of these faults on energy efficiency. Once the AMU unit is switched on, it requires minimal user configuration. AMT Toolkit is designed to acquire data with a couple of clicks. During automated learn mode, the complete normal operating condition of the connected system is established within 30 minutes. When this is complete, the software creates a complete condition assessment report for the connected equipment. Each report lists the existing faults of the motor-driven system. Unlike conventional systems, this information is provided to the user immediately without having to wait for data trends to be collected and analyzed over an extended period. This report identifies any existing mechanical or electrical problems, recommends corrective actions, and how soon such actions should be carried out. The report also provides measured electrical parameters, such as power factor, active and reactive power, voltages, currents and their imbalances, as well as harmonics. If these electrical parameters are above their expected values, a warning is issued for the attention of the user. These parameters can be used to help determine efficient operation of the equipment. Many users are aware of the connection between deteriorating condition and reduced efficiency. Excessive misalignment, voltage imbalance, or mechanical imbalance can have serious impact, as can heating caused by bearing or electrical problems. For example, efficiency is dependent on pulley size, driven torque, under and over belting, V-belt design and construction. Efficiency deteriorates as much as 5% over time if slippage occurs. Getting the most out of your assets involves parallel improvements in both efficiency and effectiveness. Artis's condition monitoring systems now provide benefits that go beyond traditional fault diagnosis to help users deliver in both these critical areas. The report provided by the AES for AMT software considers these deteriorations and informs the user.